Good morning, student. Welcome to Psychophysics YouTube channel. Okay, today I am going to discuss about the very important topic from classical mechanics, that is degree of freedom. Okay, here we will study what is degree of freedom and how to calculate degree of freedom. Okay, let's start. Our first thing is degree of freedom. Okay, first we will see the definition of degree of freedom. What is the definition of degree of freedom? The minimum number of independent coordinates required to describe the dynamics of a system is known as degree of freedom of the system. Basically, the degree of freedom of a system is the minimum number of independent coordinates required to specify the dynamics of a system. Basically, the minimum number of independent coordinates. What do you mean by independent coordinate? Suppose this is a room. First we have to understand what is independent coordinate. Okay, suppose this is a room. Okay, suppose I am standing here. Now how can I find out my coordinate? Suppose my coordinate, suppose this is north, south, east and west. My coordinate from the east side is, let's say, 50 centimeter. Okay, similarly from north side is, let's say, 20 centimeter. Okay, if I will calculate from the west side, then it is not independent. Here it has two independent coordinates. Okay, I have two independent coordinates, that is from east side and north side. If I will calculate from west side, it is not independent coordinate, it is dependent on E. Okay, I think you have cleared that what is dependent coordinate and independent coordinate. Okay, let's move to the next slide. Okay. Tricks to find degree of freedom. We can find out the degree of freedom from the question also. Okay, basically in a question we have to trace the language first. In the question we have to trace the language first. In question it has given that motion along a predefined path, or motion on the surface, or motion in space. Here we have to see the language. Here it has used that along, here it is on, in the space. In these terms will give us our degree of freedom. Okay, let's see. Motion along predefined path, where it has described that motion along predefined path, then the degree of freedom will be 1. The motion on the predefined path, on, when on is uses in the sentence, then it is obviously 2 degree of freedom. Then motion in space means 3D. Okay, let's take some example. Particle moving along a straight line. Suppose this is straight line and particle moving along a straight line. Here from the language it is given that along, hence it is its degree of freedom of the particle is 1. Similarly, particle moving along y equal to sin x curve. Okay, suppose this is the curve of sin x. Okay, a particle is moving along the sine curve. Particle is moving sinusoidally. Then its degree of freedom is 1, because it is moving along the curve, so it has 1. Okay. Okay, let's move on. Let's see the second example. The particle moving along y equal to sin x curve, it is also 1 dimension. Its degree of freedom is also 1, because it is moving along. The term here is along. A person running along a circular track. A person is running along a circular track, since here it is also degree of freedom is 1. A particle moving along x square plus y square equals to 4. A particle moving along a square equals to y square. A particle moving along x square equals to y square equals to 4. It is the equation of a circle whose radius is 2. Okay, hence it is also a particle is moving along. Okay, hence it is degree of freedom is hence its degree of freedom is particle is moving, it is moving along, hence degree of freedom is 1, because it's moving along the curve के किनारे घूम रहे हो. A particle is moving along y equal to 2x plus 3. If I draw the graph of 2x y equal to 2x plus 3. The graph will like this. Okay, this is the graph of 2x plus 3. When if the particle is moving along the straight line, hence its degree of freedom will be 1. Hence its degree of freedom will be 1. Okay, now degree of freedom in polar coordinate. We have known that there are different type of coordinate system like Cartesian coordinate system, cylindrical, spherical, polar coordinate. In polar coordinate we use r and theta. Okay, basically r is the radial coordinate, theta is the angular coordinate. Okay, let's see here. Particle is moving in any vertical plane. Suppose this is a vertical plane and particle is suspended from here with a spring and it is moving in a vertical plane. That means it is moving here. It is executing a session like this. Here the minimum number of independent coordinates required to describe the dynamics of the system is 2. Here the degree of freedom of the system is 2. How we can say that it has 2 degree of freedom? Because let the mass can move in this direction. Okay, the mass can move in this direction in the vertical plane, hence it has 1 degree of freedom, and the mass can also change the length of the string. The length of the string can be changed. Here we call this is theta and this is r. Okay, here r and theta, the two coordinates are changing, hence it has 2 degree of freedom. Okay, next, constraint and degree of freedom. What are in this topic there is term comes constraint. What is constraint? Constraint are the coordinate imposed on the dynamics of the system. Constraint are the conditions imposed on the dynamics of a system. कोई भी सिस्टम का डायनामिक्स पर जो कंडीशन इम्पोज होता है वो ही कांस्टेंट होता है. लेट्स सी, देयर आर डिफरेंट टाइप ऑफ कांस्टेंट वी विल स्टडी इन फर्दर. लेट्स सी, डिग्री ऑफ फ्रीडम of more than one particle system. Degree of freedom of more than one particle system, and sum of degree of freedom of all particles are in. Okay, fa system is f1 plus f2 plus f3 plus fn. We will see the example. Okay, when there are dependent coordinate is there, then sum of all degree of freedoms of all particles minus number of constant between them. Okay, next thing is, suppose this is a sphere and there are two particle A and B. We have to find the degree of freedom of the system. Here. Okay, in the previous slide we have seen that what is the degree of freedom? Sum of all degree of freedom of all the particles. Sum of all the degree of freedom of all the particles here. Here there are basically 3 particles, A, B and the sphere itself. Okay, it have first we have to calculate degree of freedom of A, B and the sphere also. Okay, here A is moving on the sphere. On the sphere means it has on use, hence it has 2 degree of freedom. Similarly B also has 2 degree of freedom, and here the sphere is at rest, hence it has 0 degree of freedom. Then it has 4 degree of freedom. Total degree of freedom of the system is 4. The degree of freedom of a rigid body. Basically, what is rigid body? Rigid body is the body in which the distance between 2 points remain unchanged while it is even it is in motion. Even it is in motion, the distance between 2 points remains fixed. This type of body is called rigid body. You have already studied this, I think. Okay, so general formula to calculate the degree of freedom of a rigid body is d to d plus 1 by 2. Here d is the dimension, here d is the dimension. Suppose you have a 3D object, then its degree of freedom will be 3 into 3 plus 1, that is 4 by 2, that is 6. Its degree of freedom will be 6. Suppose you have a 2-dimensional object, then you can calculate the degree of freedom like this. It has 3 degree of freedom. Okay, how to find rotational degree of freedom? Okay, basically question comes that how to find the rotational degree of freedom. For find rotational degree of freedom, I have the total degree of freedom of a system is the rotational degree of freedom, translational degree of freedom minus constraint between them. Okay, over there is a question, a child is playing with wheel on the road, then degree of freedom of the wheel or degree of freedom find out from available. Okay, let's see the question again. child is playing on the surface of the road. Suppose this is a surface of the road and child is playing with a sphere. Okay, let's say this is the sphere. Okay, now the number of degree of freedom of the system. Let's see the language here. A child is playing with wheel on the road. On the road means it has 2 degree of freedom. Okay, 2 degree of freedom. Degree of freedom कहते translational degree of freedom वाला कहते 2 because it has 2 degree of freedom. Similar rotational, how to find rotational degree of freedom? You have to check rotational degree of freedom along x-axis and y-axis and z-axis. Here let's say this is x-axis, this is y-axis and this is z-axis. Here as it is moving on the surface, okay, it is a 2D object, hence it can move along z-axis, it can move along z-axis के along उसका degree of freedom होगा. Similarly, if I'll see the degree of freedom along x-axis, it has no degree of freedom along x-axis. When we will calculate degree of freedom, it has no degree of freedom along x-axis because while we are rotating it along x-axis, then its contact with the surface vanishes. Okay, hence it has no degree of freedom along x-axis. Similarly, along y-axis, it can move along y-axis because as it is a 2D plane, hence it has 2 translational and 2 rotational, that is hence it has 4 degree of freedom. Okay, thank you. We will continue from the next chapter. Okay, in the next